Okay, today we're going to look at graphing our sine and our cosine functions. That's right, we're changing our trig ratios into functions. So before we do that, since we're going to look at graphs today, I'd like to review the effects of changing different parameters, excuse me, transformations and relations of a function in general. So here's the graph y equals f of x. What I would like you to do, that's right, virtual warm-up, is discuss with your neighbor the effects of each of these changes on the graph of f of x. Pause the video and do it. Okay, so hopefully we came to some agreement on these pieces. Multiplying f of x by 2 creates a vertical stretch by a multiplier of 2, meaning vertical y values, output. In fact, this multiplication is happening on the outside, therefore it affects the output, making our y values double, while our x values remain the same. Number 2, adding on the outside adds to the output. Output is y. So this actually translates this entire graph up 2 units. Notice both of these two effects in 1 and 2 affect the output. They are output effects, which means it affects the y value. I know this is review. Hopefully it's coming back. Otherwise, stop the video, have a little chat, and iron that out. You can kind of look back, if you'd like to our first unit. We did some sawtooth functions where we moved a graph around the plane based on these same ideas. Okay, so number 3, we're multiplying the inside. Inside affects the input in the inverse manner. What does that mean? It means that this is a vertical multiplier. I'm sorry, not vertical. This multiplies the inside, which means it affects the input. The input is the x value. So this is actually going to affect the graph horizontally. So this is a horizontal, I like to call it a shrink slash stretch, but it actually is going to happen in the inverse manner. So not multiplying by 2, but it's actually going to divide by 2, or multiply by 1/2. So multiplying by a 2 doesn't take this graph and stretch it horizontally. It's actually going to take these pieces and condense them by a factor of 2. In other words, it's going to take all of the x values, since x is the input, the horizontal component, and affect it in the inverse manner. So not multiply by 2, but instead divide by 2. Okay. Number 4. Again, affecting the input, which is the x values, and in the inverse manner. So subtraction by 2 on the inside actually produces a shift to the right 2 units. Okay, please take a moment, and what I would like you to do is sketch a graph for each of these first 4 examples. I'll pause the video to do it, and we're off. Okay, so we're going to make a sketch here. First off, we have our coordinates. And for number 1, we are graphing 2 times f of x, so 2 times the output, since it's happening on the outside. So all of these coordinates have a y value, and we're going to multiply just those y values by 2. So negative 2, 2, multiplying the y value by 2 becomes negative 2, 4. 0, negative 2, multiplying just the y value becomes 0, negative 4. 2, 2, multiplying just the y value becomes 2, 4. And we have ourselves a stretch by a factor of 2, or in other words, a vertical multiplier by 2. Number 1, complete. Number 2, a vertical shift. Well, each of these values, again, it's affecting the output. So it affects only the y value. In this case, it's being added by 2, resulting in each of these y values increasing by 2, thus creating the points negative 2, 4, Moving this one up 2 would be 0, 0. And 2, 4. Our vertical shifts. Okay. Now, horizontal shifts, very similarly. Let's see here. We need a spot to graph them. Just one moment. Okay, here we go. Sorry about that. Alrighty, so now let's do our horizontal shifts. This horizontal shift by a factor of 2, or shrink by a factor of 2, it's multiplying 2 on the inside, so we do the inverse to the input, so the x value gets divided by 2. So instead of having negative 2, 2, this x value multiplied by 1/2 would be negative 1, so we have negative 1, 2. This x value multiplied by 1/2, 0 times 1/2 is still 0, so this is still at 0, negative 2. And here, 2 times 1/2 gives us an x value of 1, so we're at 1, 2. And we could see that this graph was actually not stretched by this factor of 2, but instead taken and squished by a factor of 2. It's condensed or shortened or contracted by twice the by factor of 2, so divided by 2. All right, and lastly we have our last one, x minus 2, shifted to the right 2. I'm just going to do this one up on my original graph. Each of these points, we add 2 to the x value, which shifts them over 2 units, and this is numbers 3 and 4 on the original. Now, what we're going to do today is we're going to start by graphing, or by identifying and defining our trigonometric ratios as functions, as opposed to just ratios within a right triangle. And then we're going to apply these same ideas to those functions. So by manipulating what's added or subtracted on the inside, inside here, and outside of a function, we can create any of a family of functions. So when we did this with quadratics, we were able to take a simple quadratic, y equals x squared, and rewrite it using these transformations so that it would create any of the parabolas of any graph of any quadratic, just with those shifts. So, time for our notes. A little warm-up done. Start the next video.